Yeah, hello everyone. So now I am going to discuss some problems based on this orthogonal basis. And first question you are looking, one matrix is given A equal to 1 1 2 1 2 4 1 0 4 and 1 1 0. Sorry. So we have to calculate orthogonal basis for column space of A. And second question you are looking here, T a linear transformation defined as T of xy equal to x minus y, y and x plus y. And we have to find orthogonal basis for range of T. So these two problems, first I will discuss, then I will discuss matrix representation of inner product, and then last topic, then I will discuss orthogonal complement. So how to calculate orthonormal basis for column space of A? I hope you all are aware with column space. So first we have to convert the matrix into row echelon form, and we have to find those columns in which you will get pivot elements. So we have to choose those columns, and that will be the column space of A. And after getting column space of A, then we can apply Graham-Smith orthogonalization process, and we can calculate orthogonal basis. So let's get started. So first question is given A equal to A equal to 112 and 122, and third is given 104, and last is given 110. So how to convert this matrix into row echelon form? So we can apply row operation. R2 is replaced by R2 minus R1, and R3 is replaced by R3 minus R1, and R4 is replaced by R1 minus R4. So then what you can get? First row, we are not going to change. So you will get 1, 2 and 2, and 1 minus 1, 0, 2 minus 1, 1, 2 minus 2, 0, 1 minus 1, 0, 1 minus 0, 1, and 4 minus 2, 2, 1 minus 1, 0, 1 minus 1, 0, and 2 minus 0. So we are getting 2. So if first we are getting first pivot element, second also we are getting pivot element. Now we know that all the elements below 2 pivot, this would be what? 0. So next row operation we can apply. R3 is replaced by R2 minus R3 or R3 minus R2. R3 minus R2. Then what we can get? 1, 2 and 2, 0, 1, 0. Now 1 minus 1, 0, and 2 minus 0, 2, and we can get 0, 0 and 2. So you are looking here R2, R3 and R4 are same. So we can make 0 by applying row operation. So final last row operation we can apply. R4 is replaced by R3 minus R4. So then 1, 2 and 2, 0, 1, 0, 0, 0. This also you can divide by 2 also if you want. So 0, 0, 1, and finally you will get 0, 0, 0. So this is what, if I am asking you what will be the row space? The row space is what? Non-zero rows in row echelon form. So same time here, in the same time, you can revise your concept of row space, column space. So row space is what? Number of non-zero rows. So how many number of non-zero row? This will give you rank of matrix. And this basis for row space, you can write number of this non-zero row 1, 2, 2, 0, 1, 0, 0, 0, 1. So this is row space now, but they have asked calculate orthogonal basis for column space. So how many columns you are getting in this matrix? C1, first column, second column C2, and third column C3. So in first column, you are getting pivot element. So C1 we have to select. C2 also we are getting, in C2 also we are getting, and C3 in C3 also we are getting pivot element. So we are getting C1, C2, C3, all the columns we are getting pivot element. But column space is actually given by set of all the pivot column in the original matrix. So what we have chosen in the starting. So now in the starting matrix, you can choose column vectors. So x1 is what? First column was of the given matrix is 1, 1, 1, 1, 1, 1. And x2 is what? Second column of the this column space. We have to calculate pivot elements, but this pivot element we should not choose from the row echelon form of the matrix. We have to choose from the original matrix. So x2 will be what? Second is given 1, 2, 0, 1. So 1, 2, and 0, 1. And x3 is what given? Third column 2, 2, 4, 0. So 2, 2, 4, 0. So now we know that process. If x1, x2, x3 now we have calculated. So now I hope you can calculate. So we know that V1 is what? Just now only one I will calculate. So V1 equal to what? X1, and which is given 1, 1, 1. So this is our first vector, first orthogonal basis. V2 is what? X2 minus inner product is space of X2 comma V1 into V1 and divided by norm V1 whole square. So now I hope this question you can solve yourself, because similar type of problem we have done. So my target was to how you will proceed if you are getting column space, calculate row space, basis for row space, you convert in orthogonal basis. So first our target is to convert the given matrix into row echelon form, and then we can calculate basis, orthogonal basis for row space also, column space also, and null space also. So now you can use the formula, this Graham-Smith orthogonalization process. V2 we can calculate, and similarly we can calculate V3. So this type of question we have done earlier. So now you can calculate. Now second problem is given. We are having one linear transformation. And what is that linear transformation given? Linear transformation is given. Second problem. T of x, y is defined as T of x, y is defined as x minus y, y, and x plus y. And if we will observe here, T is a linear transformation from R2 to R3. Why R2 to R3? Because in domain set you are getting 2 component, and in codomain set you are getting 3 component. So if you are getting this type of problem, how to calculate? So in this question, actually you can clear your two concepts. First, how to calculate range space of a linear transformation, and then how to convert the obtained basis into orthonormal basis. So how to calculate range space of this matrix? So because nothing is given, if they are given some basis spanned by R2, then we can apply those bases in the domain set. But nothing is given, then we know that, I hope you all are aware, we have to apply standard basis of R square. So what is the standard basis of R square? 1, 0. So what will be image of 1, 0? X component 1 and Y component is 0. So 1, Y is 0, and here 1. Second, what is second standard basis of R square? T 0 comma 1. So this equal to Y component is 0 and X component 0, Y component 1. So you will get minus 1 and Y 0, and here you will get X plus Y 1. So next what to do? After calculating image, the image set we can write down in the matrix form, and then we can calculate row echelon form. So what will be matrix obtained by these two vectors? So first vector we are having 101 minus 101. 101. First vector we are getting 1, 0, and 1, minus 1, and 0, and 1. What is need of converting this image set into row echelon form? Because the range space is spanned by these vectors, and we need linearly independent vector, because we know that if you are having linearly independent vector, then only this can generate entire space. I hope you all are aware of spanning set and linearly independent set. So why we are converting this matrix into row echelon form? Because we need linearly independent vector in the basis of range of this linear transformation. So this you can convert in row echelon form. first no need to touch 1 0 1. Second you can add R1 plus R2. So 0, 0 plus 0, 0, and 1 plus 1, 2. And this we can divide again by 2. So finally we can get 1 0 1 and 0 0 1. So now basis for range space, basis for range of basis for range of this linear transformation is given by these two vectors. First vector is what? 1, 0 and 1, and second vector is what? 0 0 and 1. So this is the process to calculate range space of a linear transformation. If nothing is given, then you can apply image of linear transformation and we can convert in row echelon form. Now, how you will convert this range space, these bases into orthonormal basis? So again, we can apply Graham-Smith orthogonalization process. So V1 equal to what? X1, and X1 is what? 1 0 and 1. Similarly, V2 is what? 0 0 1. So V1 equal to X1. Sorry, this is not V2, this is X2. Yeah, so V1 is 1 0 1, and which is equal to X1. Now, how you will calculate V2? V2 equal to X2. X2 is given, this is second vector X2, 0 0 1. So 0 0 and 1. X2 minus inner product space of X1 and X2 and V1. So you can calculate inner product of the space of these two, 1 into 0 0, 0 into 0 0, 1 into 1. So we can get here 1 divided by norm V1. Norm V1 is what? 1 plus 1. You can calculate length of this vector. So 1 by root 2 we can get, but here because in formula we know that norm V1 is square. So we can get here 2 and into V1. V1 is what? V1 is 1, 0 and 1. So what will be V2? 1 0 1. We can verify 1 0 1 we are getting basis element 0 0 1. So this V1 we have assumed that 1 0 1 which is equal to X1, and V2 is what? X2. X2 is 0 0 1 minus inner product space of X2 and V1. So V1 we are getting 1 0 1 and X2 is 0 0 1. So this we can multiply, we can calculate inner product of these two. So 1 into 0, 0, 0 into 0, 0, 1 into 1. So we can get 1. And what is norm of this V1? Under root 1 plus 1. So we can get here 2. And this will be what? 1 0 1. So X2 V1 into V1. V1 is what? 1 0 1. So now this we can get 0 minus 1 by 2. So you can get minus 1 by 2. Second, 0, and then 1 minus 1 by 2, we can get 1 by 2. So these two are the basis for uh, range space, orthogonal basis for range space of T. So if you have to calculate column space, row space, basis for orthogonal basis for, so first you can convert the given matrix into row echelon form, you can calculate, and then you can apply Graham-Smith orthogonalization process. So these two vectors are the orthogonal basis for range space of T. If suppose you are asked to calculate orthonormal vector, you have to calculate, then you can divide by length of the vectors. Otherwise, you can leave it. So now, next topic is how to calculate matrix representation of inner product space. Matrix of inner product space. So let us assume that alpha 1, alpha 2, dot dot alpha n, these are the basis for some vector space V. These are the basis for vector space V. So matrix representation of this inner product space is defined as Aij equal to, where Aij is the matrix, this equal to inner product space of alpha I, comma, alpha j, where I and j is varies from, this is varies from 1 to n, 1 to dot dot. So these, by applying this formula, we can calculate matrix of inner product space. So if suppose you are having two vectors alpha 1 and alpha 2, then so these number of bases will define the order of the matrix. If you are having two bases alpha 1 and alpha 2, then we can calculate A11, then this is given by alpha 1 alpha 1, A12 alpha 1 alpha 2, and A21 A2 A1 and A22 we can calculate. If number of basis elements are given 3, then we can get 3 cross 3 matrix. So actually this matrix representation of inner product, this is defined, order of the matrix is defined by number of elements given in the basis. So let us assume that one problem, if you have to calculate, and one more thing you can remember, obtained matrix of inner product space is always symmetric matrix. Why symmetric? Because A12 and A21, because inner product space of V1 and V2, this must be equal to what? V2 and V1. For example, if we have to calculate A12, A12 will be what? Inner product space of alpha 1, comma alpha 2. What will be A21? A21 will be what? Inner product space of alpha 2 and alpha 1. And we know that first property of inner product space is what? Inner product space of U and V is always equal to inner product space of V and U. So these two are always equal. So A12 and A21 always equal. So in, if you are getting this type of problem, so 2 cross 2 matrix, so only you have to calculate A12 or A21, and no need to calculate these two. Similarly, if you are having 3 cross 3 matrix, then A12, A21 equal A13, A31, A21, A32, A23. So I think you can just reduce your calculation if you will know the concept, because obtained matrix is symmetric matrix. So accordingly, we can calculate. No need to calculate all the entries. Simply we can calculate alpha, only non-symmetric part we can calculate. If you are getting symmetric one A12, no need to calculate A21. If you are having 3 cross 3 matrix A32, you have calculated, no need to calculate A23. If you have calculated A21, A12 is equal. So like that only, because obtained matrix is symmetric. So let us consider one example. So first problem based on this matrix representation. Let us assume that F1 first basis is given 1 minus x, and F2 is given, second basis is given x square. And these two are the subspace of P2R. P2R means set of all the 2-degree polynomial. Now we have to calculate matrix representation by these two, F1 and F2. So how to calculate matrix representation? So first of all, after looking number of bases, immediately this concept you should get in your mind that obtained matrix will be 2 cross 2. So what will be, so this question can be asked, first question, it can be asked with respect to standard inner product space, or they will give you some inner product space. So I will calculate both. If, for example, if you have to calculate matrix representation by these two with respect to standard inner product space, then what you will do? Then this F1 we can take as a, because in standard inner product space only we have to calculate coefficient of the variable. So because this is the subspace of P2R and P structure of P2R, you know, ax square plus bx plus c. So coefficient of x square is there? No. So 0. Coefficient of x, yes, -1. Coefficient of constant, yes, 1. Similarly, what will be F2? F2 will be what? Coefficient of x square, yes. Coefficient of x, no. Coefficient of constant, no. So 1, 0, 0. So now how to calculate matrix representation? So first we have to calculate A11. What will be A11? A11 by the given formula, this is defined as F1, comma F1. F1 comma F1 means what? You have to calculate inner product of space of F1 with the same F1. So if 0 into 0, what you will get? 0, -1 into -1, so you will get +1. and 1 into 1, so you will get 1. So this is what? 2. What will be second entry of the given matrix A12? A12 will be what? Inner product space of F1 and F2. So this will be what? F1 and F2 both are given to you. So 1 into 0, 0, minus 1 into 0, 0, and 1 into 0, 0. So this entry you will get 0. Similarly, because this obtained matrix is symmetric, so A21 will be also 0. Now what will be A22? A22 is what? F2 and F2. So F2 and into F2 will be what? This F2 again you can find inner product space with same vector. So 1 into 1, 1, 0 into 0, 0, 0 into 0, 0. So now all the components you have calculated. So what will be matrix? So matrix A equal to first entry, how you will write? A11, A12, A21, and A22. So what will be this? A11 we have calculated 2, A12 0, A21 is also 0, A22 is 1. So this matrix is the uh, this matrix we got corresponding the given basis 1 minus x and x square. Same question. Now you are aware. Same question. If suppose fx was given to us 1 minus x, and second function f2 was given x square. In case if they have given you some different kind of inner product space like f comma z is defined as 0 to 1 by 2 or minus 1 to 1, something they can give minus 1 to 1, fx into gx, fx into gx into dx. Then how you will calculate matrix representation? One only I will calculate, remaining you can calculate. So what will be A11? A11 will be what? Inner product space of f with f, and this equal to what? Integral minus 1 to 1 and 1 minus x, 1 minus x. So you will get 1 minus x whole square into dx. So this we can write, you can split the square. So this we can write this equal to 1 plus x square minus 2x. So because minus 1 to 1 we can apply definite integral. So because x square is the even function, so this will become 2 times. But here x is odd function, so this will become 0. So this you can write 2 times. Integral of 1 is what? X. Integral of x square is x cube by 3 and limit from 0 to 1. So this equal to 1 plus 1 by 3. So 4 by 3 into 2. 1 plus 1 by 3, 4 by 3 into 2. So we can get 8 by 3. Similarly, you can calculate A12. What will be A12? Inner product is space of f, and second function is what given? Second function is given g. Okay, second function is given x square. So f1 or f2 or you can consider z, whatever, g. So this equal to minus 1 to 1. First function is given what? 1 minus x into x square into dx. So you can multiply this equal to x square minus x square into x cube, and this minus 1 to 1, and this is what? Into dx. Again x cube is what? Odd function, so this will be 0, and integral of x square is what? X cube by 3. But here minus 1 to 1 we can you can write 2 times 0 to a property of definite integral. So I hope final this will be what? 2 by 3. You can verify x square integration x cube by 3, so 1 by 3 and 2 times 2 by 3. So A21 is also 2 by 3. Similarly, you can calculate A22. So what will be matrix? A11, A12, and A12 and A21 same. So A21 and here A22. So this is the way to calculate matrix representation of inner product space. So I hope this concept is clear to you. So now last concept of this inner product space, orthogonal complement. So what are the orthogonal complement? Orthogonal complement. What are the orthogonal complement? Suppose if U is the subspace of a vector space V, suppose V is a vector space and U is the subspace. So the set of all vectors in V, this we can try by Venn diagram. This consider what? This is a vector space V, and this you consider what? Subspace of U. And let us assume that in U there are some vectors like U1, U2, dot dot, and in V suppose given V1, V2, dot dot, Vn. So what is meaning of orthogonal of complement U? So this is represented by U, this perpendicular sign, this equal to. So we have to find, suppose if U is a subspace of a vector space V, so set of all the elements of the elements in this subspace, which is orthogonal to all the elements of given vector space, is known as orthogonal complement. Again, I repeat, if U is a subspace, if U is a subspace of a vector space V, so and suppose in subspace you are having 100 or 1000 elements like U1, U2, dot dot, Un. So orthogonal complement means what? We have to collect all those elements of U. We have to collect all those elements of U, which is orthogonal to the all the vectors of V. Means suppose if U1 V1 is 0, U2 V2 is 0. Suppose U3, if you are having third vector in U which is not orthogonal, so no need to choose that one. So orthogonal complements, we have to choose all the vectors of U which is orthogonal to V. And this can be represented as a x belonging to, suppose if I am taking here V, so x belonging to V, set up all those elements of V, such that inner product is space of x and y, this equal to 0. What is y? Why we are choosing a random random vectors from the subspace U for all. So we will write for all y belonging to U. Why we are writing for all? So because this is not single, we can choose any. This is y is not only fixed. So this y, suppose in U you are having y1, y2, y3. So we can write x y1 is also 0, x y2 is also 0. So because of that, for all y belonging to U, so this is called orthogonal complement. Now, how to calculate orthogonal complement? Let us assume that one problem. Suppose we are having two vector v1, first problem, v1 equal to 1, 1, 0 and v2 equal to triple 1, 1, 1, 1. v1 and v2 are the two vectors for S. These two are the, because these two are the belonging to R cube. This is also belonging to R cube. And we are choosing one S subspace S, and where S equal to what? This S equal to, these two are 1, 1, 0 and 1, 1, 1. So this S is a subspace of R cube. So here we have taken vector space, we have taken V equal to R cube, set of all Euclidean three-dimensional space V equal to R cube. And in S, we are having two vectors 1, 1, 0, 1, 1, 1. So we have to find basis for S complement. S complement means we have to find orthogonal complement. So how to find this S complement? So because by using the property, so what is orthogonal complement? So first you choose one random vector of orthogonal complement, because in S all the vectors of the form of R3. So let us assume that x, y, z random vector which is belonging to R cube. Now according to S complement, inner product is space of S, this first vector to x, y, z, and inner product is space of second vector with x, y, z. This should be what? 0. Because according to the definition of orthogonal complement, if we are choosing a random vector, so this into inner product space, these two 0. So first equation what you will get? Inner product space of V1 to x, y, z 0. So this you will get x plus y equal to 0. This is first equation. Second equation, because V2 is 1, 1, 1, so we can get x plus y plus z equal to 0. This is equation second. So now solution of these two set, we can get basis for orthogonal complement. So from the first equation, you are looking x plus y equal to 0. So this x plus y equal to 0 we can use in equation third. So this will imply z equal to what? 0. If z equal to 0, then because x plus y equal to 0, so this will imply x equal to minus y. So we can assume let y equal to some random vector k. So x will be what? Minus k. So what will be basis? X, y and z. X is what? Minus k, y is k, and z we got 0. So all the vectors of this form minus 1, 1, and 0. So this is the basis for orthogonal complement, S complement, minus 1 and 1 and 0. One more question I will discuss, and also you can verify your answer. If you will check obtained basis minus 1, 1, 0 and 1, 1, 0. So inner product is space of this S complement. What was V1? V1 is given, V1 was given 1, 1, 0. V1 was given what? Yeah, V1 is given 0, 1, 0, 0, 1, 0. One second. Yeah, V1 is given 1, 1, 0. So if you will calculate inner product space of V1 to this obtained basis, so V1 was what given? V1 is given 1, 1 and 0. So if you will calculate inner product space of these two, then what you will get? Minus 1 into 1 minus 1 plus 1. So always you will get inner product space of this obtained basis of S complement to V1 and V2. This should be 0. This must be 0. Then we can say our answer is correct. Next example, last example. So suppose the V, if I will assume that V equal to R cube, let us assume that V equal to R cube and W is a subspace of V such that if I am assuming X, Y, Z, which is belonging to R cube, such that X equal to Y equal to Z and X minus Y plus Z equal to 0. Then what will be W complement? So if you are having these two vectors, then how you will calculate W complement? So first we can solve these two equation. How you will solve these two equation? X equal to Y equal to Z and here X minus Y plus Z equal to 0. So because X equal to Y, so if I will use here X equal to Y, then Z will be what? This will imply Z equal to 0. And Z equal to 0, we can use in second equation, so we can get X equal to Y. So X equal to Y and Z equal to 0, or we can use here Z equal to Y, so Y cancel, X equal to 0. So we can assume that here. So what will be solution set of these two equation? Solution set of these two equation will be what? Solution set of these two equation we can take if Z equal to 0. First we can get 0, 0, 0. 0, 0 is what? If I am choosing here 1, 1, 0, 1, 1, 0 is also basis for this W, because 1 and 0 is satisfying or not satisfying? Not satisfying, because here X equal to Y equal to Z. So only possibility is what? Solution of these two, X equal to Y equal to Z and X minus Y plus Z equal to 0. What is solution of these two equation? 0, 0, 0. So now what will be the basis for W complement? So because W we have chosen from R cube, so you can assume X, Y, Z, a random vector which is belonging to what? R cube. So according to the definition of S complement, W complement, so this inner product space of this and this should be what? 0. So what you will get? X into 0 plus y into 0 plus z into 0. This equal to what? 0. So what will be W complement? W complement, we can choose any random vector of R cube, we can choose any three-dimensional space, and we can multiply with this 0, 0, 0. Always we will get 0. So W complement, what we can say here, because W in W we are getting 0, 0, 0, only this vector, and W complement we have to calculate, so we can find x, y, z random vector, we are getting 0. So this W complement we can take entire space of R cube, because you can choose any vector of R cube, and if you will take dot this inner product with 0 comma 0 comma 0, then always you will get 0. So this W complement we can say this is entire space of R cube. So now this topic is completed. Inner product space, Graham-Smith orthogonalization process, and then matrix representation and how to calculate column space and null is orthogonal basis for column space, null space and row space. This also you can calculate. So if you have any doubt or any query if you want to ask, you can share your question, and thanks for watching.